make it to this. We are recording it, though I just skipped the first 5 minutes. I even tried to remind us to do it. Okay, now we're recording. And just a reminder that if you're on the call, the recording does not capture like the messages, or it just captures the audio and the visual from my computer. Cool. Okay, we're gonna move on. So where we start in the video series is getting on the same page about avalanche hazard, and that's really the foundation. So having an understanding for the terminology with avalanches and having a baseline understanding of what avalanches are and why they're dangerous. So we have different types of avalanches, and it's important to understand what the conditions are that lead to different types of avalanches. The primary avalanche type that's most dangerous for us recreating is dry slab avalanches, but we can have loose avalanches, we can have slab avalanches, and then we can have wet and dry of both of those types. And we spent a lot more time going in depth about like those terms and what the kind of mechanics of those different avalanche types are. But ultimately, an avalanche is just snow moving down a mountain. There's just different setups and different mechanics that lead to these different avalanches. So, and I think too, before we move fully on, just because dry slab avalanches is what most people are caught and killed in, doesn't mean we want to discount the other like loose snow avalanches as not being dangerous, because loose snow avalanches can still be pretty dangerous. Wet snow avalanches can be really destructive. It's just most of the time when we have big wet snow avalanches, wet slab avalanches on the table, people are not moving through the mountains because the skiing and riding is deteriorated depending on where you live. Like where I used to work in California, it was much more common to see wet slab avalanches, for example, than in Montana, because we would get rain on snow more frequently. Just depends on where you live, like how much you're going to interact with these different avalanche types. So our video series kind of started with that broad introduction video. Does anyone have questions on those kind of like really foundational topics of like what avalanches are? We're going to dive more into snowpack with the snowpack recap. But first, we're going to talk about terrain. But I wanted to open it up if anyone had any questions on the kind of first topic. Okay, terrain it is. So Ella's terrain video had some really cool visuals. So we want to define avalanche terrain as places where avalanches start, run, and stop. The start zone is those classic like steep slopes where avalanches are starting. So the track is where the avalanche is running, and the run out or the debris is like the deposition zone is where the avalanche comes to a stop. So the end of the run out of that avalanche path. And this picture is a really obvious avalanche path because it has treed terrain and there's a steep slope with a slope under it that doesn't have the same pattern of vegetation or trees. So that's like as obvious of an avalanche path as you're going to get. If you're in alpine terrain, it may be a lot less obvious because there may not be trees. So the terrain basics, like what we're kind of ground truthing, the type of terrain we're in is going to be based off of a lot of different factors. And the most important is going to be like how steep is the slope. So these other factors are really important. Like I think maybe in this list of factors, it's like the next most important one I actually think is the consequences of the terrain. But being able to understand that there's different patterns based on the aspect and elevation of a slope is really important, kind of as an entry level starting to learn that you're going to see patterns based on these different properties or characteristics of avalanche terrain. And the kind of vegetation component goes into like, how do we identify what avalanche terrain is? And slope angle is part of that, but using visual indicators, like I was saying with the avalanche path in the last picture, that's another really useful indicator of a slope avalanching, is that you see vegetative patterns of an avalanche path. Cool. But yeah, the kind of like most important factor here is it steep enough to slide, or is it connected to a slope that's steep enough to slide? So by connected, I mean it's in the fall line of the steep slope. Fall line being like if you were to drop a ball and it would roll down the hill, where's it going to go? So steep enough to slide is 30 degrees and up. Most slab avalanches are happening in that 30 to 45 degree range. And that's mostly because the snowpack can't build layers on steeper slopes because you're having multiple loose, like many loose avalanches over time. And it's not that you can't have avalanches on steep slopes. It's just statistically, most avalanches are happening in that 30 to 45. That's what this chart really means. On those slopes that are lower than 30 degrees, what's going on there is it's not impossible to have avalanches, but the friction of the slope is holding the snow there, and like the kind of the snowpack can't overcome the frictional force holding the snow on the slope. So even if you were to get a snowpack collapse, you're not going to get it to start sliding for the most part. There's like some exceptions to that when you have liquid water moving through a snowpack. Like we were talking about with wet avalanches, they're a little bit of an interesting beast. But so we consider avalanche terrain to be, those starting zones are going to be 30 degrees and up. And we want to be aware that there is connected terrain. So if we're defining avalanche terrain as places where avalanches start, run, and stop, we want to know where they're going to start, but we also want to see the whole picture of like, am I on a relatively low angle slope, but above me is a 39-degree slope, like in this picture. So I think this is like maybe one of the more important takeaways is like being able to identify avalanche terrain out in the field. And hopefully this weekend you get a chance to do that, because we'll be moving around through the mountains. It depends on the amount of visibility we have. If there's like, on Saturday, if it's snowing really hard and we don't have great visibility, it may be harder to see connected terrain or steep slopes. But this is like, if there's one thing I hope people can take away from a field-based course, it's being able to identify avalanche terrain a little better. Sweet. So I know this slide says keep it simple, and then it's got like a really long list of things on it. But like at the end of the day, we want, like I was saying, we want people to be able to identify avalanche terrain, and start being able to identify what the consequences of that slope could be if it avalanches. And then we want to be able to use good travel practices based on the type of terrain we're in, whether we're in avalanche terrain or not. How we're moving is going to change. So that's kind of the plug of like, what are we going to do to reduce our exposure to avalanche terrain if that's where we're finding ourselves? Any questions about terrain? In one of the previous pre-course meetings, I had a really good question about, that's Mark, I'm going to get to your question in just a minute. I'm going to finish my thought. So it was a really good question about like the travel habits of other people. Like this person was noticing that there's a lot of places where you can go skiing where there are people putting like skin tracks or up tracks on pretty steep slopes. And it's just worth recognizing that like we hope as a student in an avalanche course, you gain some tools to make independent decisions for yourself, and you are not always going to know why other people are making the choices they're going to make. So being able to like have a ground truth of like, is this avalanche terrain or not? that's a very useful tool. Okay, so Mark's question is, how does one predict run out distance? Ooh, that's a really good question. So in North America, just like a statistical average of avalanche run out is about 20 degrees from the start zone. But there's some exceptions to that. If you have terrain that channels avalanche debris, you could have larger runouts or larger extent of uh, avalanche debris flow. So it can be really dependent on the specific piece of terrain. But the kind of general average is about 20 degrees. The term we use for that is called the alpha angle. We're not going to get too far into it, but I did want to answer your question. You can also use vegetative indicators of like, are you seeing lots of small trees still, or trees that have cracks or flagging? There's a variety of ways we can determine if an area could be impacted by an avalanche. And then we have to relate it back to the conditions that we have. Like, do we have enough snow on the ground to produce a large avalanche? So it's a complicated question, but it's a really good one. Okay, I think we'll wrap up terrain. Ooh, that's another good one. And I think we'll talk about this one a little bit with snowpack too, and specifically with different avalanche problems. But Alexi's wondering, can you speak a bit about remote triggers from below avalanche terrain? So a remotely triggered avalanche is when you trigger an avalanche not by being on the steep slope yourself, but by being below it. And the snowpack is connected. So the snowpack's connected over space. And if you trigger a collapse, that collapse can move up a slope or move across a slope and cause an avalanche on a steep slope. We end up seeing remotely triggered avalanches most often with persistent slab avalanches. And that has a lot to do with the connectivity of those different weak layers across up slope. That's a really good question. Alexi, I don't know if I fully answered your remote trigger question. So let me know if you have other questions. But we might talk about it a little more with different avalanche problem types. So I think the next thing we're going to talk about in our avalanche triangle here, we talked a little bit about terrain. And we always want to talk about terrain first because it's the thing that we can control the most. We can't control the snowpack or the weather. Like those are just factors that are very outside of our influence as recreators, and we can control the terrain we're putting ourselves in. So the next one we'll talk about is weather, and this is just like a super quick recap of mountain weather. So the kind of most important factors with mountain weather are, is it snowing? Is it blowing? What's the temperature? Especially above freezing temperatures or drastic temperature shifts, that's really what we're concerned with. And our weather is the architect of our snowpack. So we're going to be seeing the snowpack change and be layered over time based on the weather conditions we have. So when we think about recent weather, it's, you know, the faucet turned on sometime last week or 10 days ago. And it just, like, I live up by Bridger Bowl and it's just been snowing like every day. And more snow equals more avalanches. And so part of that is just you end up having more weight on the snowpack. And you have continuous loading or weighting of the snowpack, and that causes more avalanches. So most avalanches are happening during or immediately after storms. And that is often just because the increase of load. So we'll get to see some pretty like interesting snowpacks this weekend just because we've had a lot of snow recently, which is awesome. So when we're talking about like loading, what we're talking about is like the weight of, we have our, and we'll talk about it a little more with the snowpack recap, but we have our layered snowpack, and our recipe for an avalanche is weak snow with strong snow on top of it. And when we put extra weight on top of that, that's when we collapse the strong snow onto the weak snow. And we can have that layering even within a storm. But yeah, that's what we're focused on with snowfall, is like how much snow and how much water. And the more water is in the snowpack, the more weight, or the more water that's in that storm, the more weight that we're going to see put on our layered snowpack. So the other important factor is it blowing? And typically in Southwest Montana, it's pretty windy, like relatively pretty windy. And wind also creates that recipe for an avalanche by having stronger, harder packed snow over weaker snow. So in this picture, we have a couple like visual indicators of the wind direction. So when you see cornices on ridge lines, or you see wind pillows or cross loading, or you see a textured snow surface, those are all visual clues that it's windy. And when we're talking about wind, what we're really thinking is like, is there snow that can be transported? And is the wind blowing hard enough that it's transporting the snow? And that's often something we can see visually. Generally, like the ballpark for wind, like consistent wind loading is like 15 miles an hour, 10, 15 miles an hour or higher. We can often get such strong winds that it's not even reloading like directly adjacent to where it's scouring. Like you all have probably seen wind blowing off the Bridger Ridge from Bozeman, just like taking the snow particles and throwing them into the air. And who knows where those ones land. But generally, when we have more wind, we have more, like we see wind affected snow. Like the higher the wind speed is, we see more wind affected snow in more places, even in more sheltered places. So the last of the three kind of major weather factors. So we have like, is it snowing? Is it blowing? What are the temperatures like? And really like the kind of main question is it above freezing or is it below freezing? And have we had like a large temperature swing? Especially those above freezing temperature swings. And that what's going on there is like we're getting liquid water in the surface of the snowpack, and that can be really destabilizing. And so that can create these roller balls or wet loose avalanches. It can also refreeze and create crusts, which is like bad for skiing because no one likes skiing on crusts. So that's something we really want to be focused on with temperature, especially in the springtime. Those like extended periods of non-freezing temperatures, especially the first time that's happened with a dry snowpack, that can be particularly dangerous. Okay, so kind of the major take home from this section is like, what are we going to do about the weather? We can check the weather before going out for the day. The great resource for that is checking the avalanche forecast. And then in the field, we want to be thinking about like what weather contributes to avalanches. And that's heavy snowfall, strong winds, rapid increase in above freezing temperatures. And we want to be able to recognize those conditions and when they're causing unstable snow, like instability, and then be able to, make adjust our plans for the day or dial back our exposure for the day. So that's the major points for weather. Does anyone have any weather related questions? And I find that the weather often ties in well with the snowpack discussion. So if you have any weather or snowpack questions, we can just kind of answer them at the end too of this next segment. So our snowpack, like I was saying, our weather creates our snowpack. And you see that in this picture, you have a snowpack with different, like visually different looking layers. And those different layers are what can create avalanches. So when we think about the recipe for an avalanche, I talked about some of the components earlier, but what we really need to have is steep enough terrain to slide. We need to have strong snow or a slab, weak snow, and then we need to have some kind of trigger. And whether that trigger is us skiing on the slope, or increased loading of a slope from a storm or wind, it's kind of like we just need the extra weight to tip the scales and cause that slab snow to collapse on the weak snow, and then the steep slope it slides. So already talked about this a bit, but like different storms and different conditions, storm, wind, temperature, it all creates different layers within the snowpack. And so we can have this big layer cake of a snowpack. The really important take home is that once the snow falls out of the sky, it's constantly changing until it melts. And snow can go kind of two directions. It can become stronger or it can become weaker. And the process by which snow gets weaker over time and creates these persistent grains of snow, we call it faceting. And we often see faceting in our snowpack in Southwest Montana. So it's important to be able to recognize what that looks like and the conditions that create it. So a big part of what I'll talk about in a minute is just those different avalanche problem types, and kind of the take home for students is that they can recognize when those conditions exist or what creates them, or be able to read about it in the forecast and relate it to what they're seeing. But ultimately, the layering we need to have avalanches is going to be that hard snow with softer snow under it. And it can be even like, this is Erica's, from Erica's video. I like this, the soft with even softer under it is still bad. It doesn't have to be obviously hard or strong snow. It's just relative from the snow that's underneath it. And in the field, we'll get you in pits to look at the layers of the snowpack, and we'll see if we can hunt out any of these, hard over soft combos. And that's going to be where we see avalanches breaking on those soft layers with hard snow on top. So the main thing that I wanted to recap is just touching on avalanche problem types. So this is how avalanche forecasts talk about the nature of avalanche problems. And these different kind of characteristics of different types of avalanches are really good communication tools so that you can lump, patterns or traits together. And we already were talking a little bit about faceted snow, or our persistent weak layers. And we really want to differentiate the characteristics of those types of avalanches from, say, storm or wind slab avalanches. Like the question about remote triggers from Alexi. So we often end up seeing remotely triggered avalanches with persistent or deep persistent slab avalanche problems. And those are the type of avalanches that we may want to give avalanche terrain. Like if those types of avalanches are on the table, we're seeing those, we want to give avalanche terrain even more space. Versus, for example, if it's snowing and blowing like it has been, oftentimes the instability will heal on the matter of, hours to days after a storm, rather than these persistent slabs that are named that because they persist over a long period of time. So it's just recognizing the difference based on the setup you have. And that's like the really important take home. And this is the communication tool that avalanche centers use to talk about different types of avalanches. So I'll just kind of wrap up the weather snowpack with like, what we really want you to take away is that the snowpack is layered and really dynamic, and it can be different depending on where you are. So we'll show you an example in the field of a layered snowpack, but understanding that the layers of a snowpack can be different even just 100 yards away, and that the snowpack is really dynamic and always changing. And what we really want to ask ourselves is like, do we have the ingredients for an avalanche or not? And be able to recognize unstable snow when we see it, and then be able to use the forecast to help us kind of hone in like where we would expect to see that and what we do to avoid um, being on steep slopes with the ingredients for an avalanche. So any questions about snowpack? I know this is like a really big topic. I'll give it a minute in case a question pops up. Okay, so we have talked about kind of the external part of our triangle here. So these other factors, but what we haven't really talked about is the trigger or us, and how, oh, we got a question. So the question from Peter is, are persistent snowpack problems usually a result of early season conditions? They can be. So I'm going to go back to our chart here. So um, basically, these persistent weak layers, we have a couple different types of them. And I know Erica just like briefly touched on them in the video, but they can be formed throughout the season. And we often have um, buried weak layers that form in the early season in the form of faceted snowpack. Um, because when there is not very much snow on the ground and the temperatures are really cold, the snow becomes weaker. And so we'll often bury weak layers right away at the beginning of the season. In many parts of our forecast region, we do have buried weak layers right at the ground. Um, the bridgers might almost be an exception because the snowpack got deep enough soon enough and we had relatively warm temperatures. But in the bridgers, we have a buried like mid-pack weak layer. And that was formed during the period after Thanksgiving when it was cold and clear for many days. So we'll often have buried weak layers from different weather events, or like how many of you have ever seen surface hoar, the like really beautiful feathery crystals. If we can bury those intact on the surface of the snow, those can become a weak layer, a persistent weak layer. So it really depends on the specific type of weak layer and the history of the snowpack. That's a really good question. Okay. Back to the human factor. And feel free if you have lingering questions about anything we've already talked about, feel free to just ask them and we'll just kind of like get to them as we can. So I think this is like the topic of human factors is kind of like human factor in decision making is kind of like the meat of most avalanche courses is like we want to learn about the hazard, but we also want to learn about like what we can do to reduce risk for ourselves. Um, and the kind of bottom line is oftentimes our own choices or our own desires kind of lead us away from making these simple decisions to reduce exposure or reduce our vulnerability to avalanches. So like in the video series, we talked about these different factors that we see in accidents, and we'll kind of just do a quick recap of those. But ultimately, when we're talking about the human factor, it's, our bias patterns or beliefs that are how we make decisions that aren't always rooted in reality or rooted in like the information we're gathering about the snowpack or the mountains. So I'm going to just breeze through these, but the kind of major factors we see in accidents, this is like just from our local accidents, but I think you could draw these trends from accidents all across the US and North America, like most places where people are getting caught in avalanches as recreationalists. These like same factors are going to come up again and again. And so the kind of main one that I think we can address with courses like this is lack of preparedness. So part of that is not having all the avalanche rescue gear, not knowing how to use it, and not being prepared to enact a rescue, or poor communication or no plan or poor plan for a day out. And I think when I think of these couple recent avalanche fatalities we've had in the United States, we've had 3 fatalities in a row of solo skiers or riders. And that fits under this, like, you don't, if you're riding by yourself, there's no one to perform a rescue. So you're essentially not prepared to enact a rescue because you don't have the resources to do an avalanche rescue when you're riding solo. Um, and so it's just part of this big picture of preparedness of like, how do we reduce risk by stacking the odds in our favor with having the ability to perform a rescue, even if we, not, 99 times out of 100, an avalanche isn't going to happen. We need to be prepared if we're in that type of terrain. So the other component here is like people not being aware of the hazard or the severity of the hazard or the consequences associated with avalanches. And I really think what I see again and again is people underestimating the consequences of an avalanche, like not fully recognizing how dangerous a slope is and thinking, oh, I could handle that if the slope avalanches. And avalanches are really like forceful natural events. And it's like kind of the recent data set is showing that a lot more people die of traumatic injuries than we'd previously thought in avalanches. Um, and avalanches, like the kind of like we want you to know how to do avalanche rescue and be prepared for that, but ultimately we want people to avoid being caught in avalanches in the first place because it can be so dangerous, and life-threatening. And so the other component of this is like, if you're not aware of the hazard because you're not taking obvious signs of instability seriously, or you didn't read a forecast, or maybe there wasn't a forecast in the area you were going. So it's just not having full awareness of the avalanche hazard. And the kind of final one is the failure to recognize avalanche terrain. I think it's like theoretically really easy to be like, I'm going to avoid avalanche terrain today. But in practice, it's much harder to do that, especially when you're in more challenging or complex terrain. So if avalanche paths aren't as obvious, it can be hard to know if you're exposed to avalanche terrain or not. So just really increasing your level of terrain awareness, and that just takes time. And part of that is taking avalanche courses, and part of it is just spending time out in the mountains. So yeah, those are the major factors. And what we want to introduce to you all in the course is like having a process to help reduce the risk, and help kind of combat those factors at play, like those kind of traps that we all fall into. So the process, and this is from Avalanche Canada, and we're using it because it's just an awesome flowchart and an awesome process. We want people to plan ahead before they go out, and then practice these, good habits while they're out. And then afterwards, reflect on your day so you can keep learning and growing. We mentioned it in the video series, like recreating in the backcountry is, and in avalanche terrain is what's called a wicked learning environment. You often, my dog's barking, you often could ski a slope many times in unstable conditions and not trigger an avalanche. And you may not get signs of instability until you trigger an avalanche. So being able to kind of like have a good process and an opportunity to reflect on the choices you made during the day can help create more learning that you're not necessarily going to get from the environment. So we're just going to walk through a couple of these steps, and you're going to spend more time talking about this during the field day. So before you go, we're checking the forecasts, we're making a plan, we have all the gear for where we're going. So when we look at the avalanche forecasts, we want to know, what are they seeing? What are the avalanche forecasters seeing? What are the observations that have come in? Because basically, avalanche forecasters are taking all this information and they're trying to make it really streamlined so that you're getting, within a paragraph, you're getting the major points about what's going on. They're going to tell you what's the nature of the avalanche problem, how big is it, how bad is it, where is it. They're going to tell you how the weather is going to change the conditions. And they're going to have a North American danger scale hazard rating associated with that. So that's going to be these highlighted boxes hyperlinked, so you can read through what that travel advice is. And so these forecasts are going to give you, a big picture view of, on a range scale, what are the conditions like and what is the travel recommendations based on the conditions. And so what you need to do is take that and try to make a plan for your day. And this is like the hardest part of the process, is like being good at taking the information you're getting and trying to make a reasonable plan based on what you know, what your group's like, what you're trying to accomplish. And then the meat of it is like, can we make a plan and actually follow it or execute it? And that can take many years as a backcountry skier or rider to get good at doing that, at planning and execution. And I think at this level, what we think is most important is like, do we actually have the knowledge and ability to actually be able to go where we say we're going to go, or avoid the type of terrain we say we don't want to be in? So particularly, like, if we say we want to avoid avalanche terrain, actually being able to do that in practice is often, like I was saying, quite difficult. So it's like being able to stack the deck in your favor with a conservative plan. So the other kind of pre-trip consideration is like making sure everyone in your group has all the equipment they need. So it's like, you know who your group is ahead of time, you've made a plan ahead of time, you've confirmed that you have the right gear ahead of time. This shouldn't be like show up to the trailhead and like hope that they have a beacon shovel probe. It should be communicated well ahead of time of like, this is what we're bringing with us. And often, because of where we all live, like, we're carrying a lot of stuff with us, because the winter can be like pretty nasty in Southwest Montana. And I know that I usually pack, I like to pack as if I could end up spending a night out. So I'll end up carrying a little bit of extra stuff just so I could survive a night out. But the kind of basics for avalanche gear is beacon, shovel, probe. And any modern gear that's on the market is going to like hit the criteria we recommend. And that's a modern digital 3 antenna transceiver, a metal shovel. Ideally, like the extendable shovels are really nice because they are easier to dig with. And then just a modern probe. You're going to want, like, I don't think they actually sell probes that are less than 240 centimeters now. So just a longer probe. And just with all this gear, you just got to take care of it. It's expensive equipment. It's life-saving equipment. Make sure that it works. Yeah, and then just another plug for, like, you don't need to be as prepared as this search and rescue group in the slideshow. But you want to consider, like, what do I need to bring with me in case something bad happens, so that I'm prepared. And then, yeah, I think Alexis in her talk did it really well. Just like, make sure you have a system for what your plan is and what you're bringing with you. Because humans make mistakes. We can forget things. We want to make sure we have all the stuff that's really important. So having a system, like, had an old coworker who had a list on his car dashboard of everything he needed to bring with him, and we would get in the car and he would check it every morning and make sure we had everything. having checklists is awesome. And then like the final plug with before you go, like just making sure we have all the gear that we need. Doing a beacon check. We'll show you how to do a quick, efficient beacon check. The beacons aren't going to save your life or your partner's life if they're not turned on. So making sure we have all the gear and it's working right. Okay. Does anyone have any questions on the kind of pre-trip part of the process? Okay. So what we really want to focus on with the scope of this course is those good travel habits. So being able to recognize avalanche terrain and um, base your travel decisions off of the forecast and the plan you made for the day, and actually be able to build in a buffer for yourself. That's what we're talking about with this margin for error of like, say you want to avoid like the slopes in this picture, you want to avoid steeper, rocky slopes. Are you actually setting yourself up with a plan to do that where it's easy to do that? Or have you not maybe given yourself as good of a plan as you needed to avoid those areas? So always having plan A, B, and C for your day out. And I think the really important thing with safe travel practices is like, are we protecting ourselves from bad consequences with the way we're moving through the mountains? So that can look like, are we traveling one at a time underneath a steep slope if we're going to travel underneath a steep slope? Or have we talked about how we're going to move through a section ahead of time instead of just being surprised by it? So I think that's really what we mean with good habits. So in Alexis's video about avalanche rescue, a kind of alarming data set from the last 10 years is that we have a problem with multiple people being on steep slopes at a time. And if you have multiple people on a slope when it avalanches, rescue is much harder to perform effectively. And so why we really want to hammer identifying avalanche terrain is so that we can adjust how we're traveling accordingly. So if you're going to put multiple people on a steep slope at a time, you better feel really confident that it's not going to avalanche. And if you have like what we were talking about, if you have the type of conditions where you're expecting remotely triggered avalanches, you want to be moving with a big group like well away from where steep slopes are in case you could remote trigger an avalanche and it could come down on your group. So like you really want to adjust your travel habits based on the terrain that you're traveling through and the avalanche conditions that you have. Because rescuing one person from an avalanche is going to be hard enough. We really want to avoid having multiple people caught in an avalanche at once. And so this data is all just from mtavalanche.com. So yeah, like at the end of the day, like good habits, you're not going to learn from watching a video series or taking even a single field day. You can start learning them, but it's really about just using them in practice. Does anyone have any questions about kind of travel habits or recognizing avalanche terrain, those kind of questions? Because the kind of final part of this is being able to make in-field assessments. And like what we really want to base that off of is, do we know unstable snow when we see it? And can we use those like indicators or red flags as ways to change our decision making or dial back our exposure? So the kind of major red flag is recent avalanches. So if we're intending on traveling on a slope that is similar aspect or elevation or has similar avalanche, problems on it, and we've seen an avalanche on the same type of slope, we could expect the snow to be unstable in similar terrain. So recent avalanches, we're talking about within, the last 24, 48 hours. That's what we're talking about with recent. The other component of that is the cracking, collapsing, or womping of the snowpack. That's, you have all the ingredients for an avalanche, just not steep enough slope. That's what we mean by a woomph or a collapse. It's like the collapse of the snowpack, not steep enough slope to slide. Um, Another red flag, like we were talking about with the weather section, is a lot of recent snow. And I put or rain on this because anytime we have liquid water get in the snowpack, we can expect the snow to become less stable. So a lot of recent snow is going to be that threshold could be different based on how heavy the snow is, how much water's in the snow. Let's see if my video plays. There we go. Um, and then another red flag would be we're watching the wind transport snow and build up those wind slabs. And then, like our weather factors, the last major one would be our rapid thawing. So when we see roller balls on the surface of the snow, or we can kick little wet, loose avalanches, and we have water in the surface of the snowpack, that's a sign of instability. So, kind of the important thing with this is when you see these signs of instability, it's time to dial it back. Time to, if avalanche terrain was in your plan for the day and you see red flags, those are a good indicator it's time to reduce exposure to avalanche terrain. And I think about it with, we'll go back to this red flag, rapid thawing. So if you're seeing rapid thawing on a south facing slope and it's you're seeing it on a south facing slope, but you go over to the north side and it's still dry and you're not seeing water in the surface of the snowpack. Maybe it's just the south facing slope that's now off the table because it's gotten too wet. So we want to be able to actually make real-time decisions based off of these factors. And this is in addition to the plan we already made for the day. So the one thing we didn't really talk about in the video series that we'll talk about a bit in the field is when we don't see obvious signs of instability, we often need to go do more investigating. And that's the utility of digging pits. And so we'll show you a quick pit in the field and get you to see layers of the snowpack. But what we really want to hammer home is that digging a snow pit is great to get information about either the history of the snowpack or to verify what you're seeing in the avalanche forecast in that one place at that one time. And it's a limited tool for active decision making because of the variability of the snowpack across a terrain feature. You could have really different snow structure from one place to the next. And a singular pit isn't going to capture that information. And so when avalanche forecasters go out in the field, they're digging oftentimes multiple pits and they're digging pits iteratively and doing stability or what we call instability tests over time to develop trends and make observations. They're not using those pits as a singular decision-making tool. And I think that's what's really important for us to recognize is this is just one piece of the puzzle. And then the final plug there is that observations, whether or not it's a pit or you're seeing red flags, that's really useful information for the Avalanche Center. So any questions about kind of the every day out process of we're making a plan for the day and then we're enacting that plan and we're looking for signs of instability to dial back our exposure as part of that plan. Any questions about that? Okay. Well, the final kind of way to finish off this process is just the reflection piece. And we all ski and ride because it's fun and we want to have fun out there with our friends. And we always want to be able to get to ride another day. And so why we want people to develop a process. It doesn't have to be exactly the process that we show you or the process I use, but it's some kind of process to be able to help us manage risk for ourselves, so that, you know, we don't just make impulse decisions that don't have like, that aren't like supported by, you know, the information that we have. um, and that's really the goal with all of this. It's not to like make the fun thing you want to do in your free time more regimented. It's just to bring in a better process to keep yourself safer. Okay, the final part of this is just going over a quick recap of avalanche rescue. Does anyone have any questions before we dive in? All right, then we're going for it. Um, yeah, I've said it already, but we teach people avalanche rescue because you have to know the tools and the technique. If you're traveling in the mountains in avalanche terrain, you have to know how to do avalanche rescue. But it's much easier to stay out of trouble than get out of trouble. So we really want to avoid being caught in avalanches. And like I was saying, we really want to avoid having multiple people on a steep slope or in avalanche terrain at the same time. So looking at recent avalanches in our advisory region, this is kind of just like the breakdown of user group. We have, you know, people of all different user groups getting caught and killed in avalanches. Um, Last year, we had a really unstable snowpack and we somehow didn't have any avalanche fatalities, which was pretty miraculous. But when we look at the big picture, like why we want people to know how to do rescue is your chance of survival goes down drastically after being buried the first 15 minutes. And it's not to say it's impossible to survive longer duration burials, but your best chance of surviving a full burial in an avalanche is getting dug up as fast as possible. So if you're caught in an avalanche, what you need to do, if you are skiing with an airbag pack, as soon as the avalanche is breaking around you, that is the time to pull that airbag trigger. If you are skiing on a slope and you notice it starts sliding, the best possible case scenario is that you can traverse or ski off the slope. And before you go into avalanche terrain, you should really ask yourself, like, what's it going to look like if this slope slides? What are my escape routes? What's my best option? So it's really going to depend on where you are on the slope, either if you're going to try to traverse off the slope or arrest, like stop yourself on the slope, because only the snow above you can bury you. So if you are fully caught, hope that your skis just, you know, your bindings release and your skis come off your feet. It's a major consideration if you're snowboarding that snowboard is stuck to your feet. The skis or snowboards attached to our legs can definitely injure us if we're caught in an avalanche. We really don't want our poles to be like the pole loops through on our wrists, because those can also injure us. Once you're caught, it's going to feel really turbulent. It's going to be like being in a washing machine, or like if we have any whitewater or ocean goers, like being caught in really turbulent water. That's what it's going to be like. And you're just going to be trying to swim and make yourself big and try to get towards the surface. This is going to be really chaotic, and you're probably not, there's not going to be much time for like rational decisions. It's going to be very impulse decisions. As the snow starts setting up, there's some evidence that if you can create more space in front of your airway, whether that's by throwing an arm up in front of you, or throwing an arm towards the surface, if you know where that is, those are like tools that can help either prolong the amount of air you have when you're buried or make it easier to find you. Like if some part of you's on the surface, it's going to be easier to find you. And yeah, does anyone have any questions about what to do if you're caught in an avalanche? Okay, so the other side of the equation is you have a partner who's caught in an avalanche. The rescue is going to be in a couple steps. The kind of start of it is going to be the initial stages of like delegating tasks if you have multiple people in your group, and ensuring that you're not going to do further harm by putting yourself on the slope. That's going to be a really hard decision to make. Ultimately, like I think most people are going to choose that they need to go and rescue their partners immediately, but you are not going to be an effective rescue team if you get injured or buried while you're trying to rescue your partner. So that's just something to consider. You also need to consider like how many people you're with, what are their skills, what's going to be the best course of action, and you don't have very much time to do this. So it's worth having like a really initial conversation of like, this is how we're going to split things up, and this is how we're going to go get to the last scene point where we last saw that person, because that's going to be more or less where we start our search. So then there's the search component, and then the excavation, and then what happens after, which is arguably maybe the hardest part, is going to be dealing with somebody who is pretty injured or may not be breathing when you dig them up. So with the search, we're going to break it into a couple different components. This is for a beacon search. So if you have like a visual clue, like say somebody's, gloved hand is sticking out of the snow, or you can see their airbag, you obviously know where they are. So you don't need to do a beacon search, and you can just go straight to them and get them an airway. With with the search techniques here, this is if you don't see somebody after their point last seen and you need to go find them. So you're going to start, go to that last seen point as fast and safely as you can. And then from there, you're going to start your search. So in this graphic, the last seen point was way at the top of the hill. And we need to find a beacon signal. We need to do that while keeping the range of our beacon in mind, because we don't want to go past them, because it would be, if we're going down the hill, it'd be a lot more work to walk back up the hill. Once we have a signal, that's when we start doing our course search. So once we have a signal, we're trying to just get as low of number as possible. So we need to keep in mind that we're not going to go on a straight line there. We're going to follow the arrows and numbers of our beacons. So once we get really close, our technique has to change a little bit, and we have to slow down. This is called the fine search. So we're going to get on the snow. We're going to be crawling, and we want to only change one variable at a time. So we'll go with ourselves on the surface, with our beacon on the surface of the snow. We're going to go across the slope till we get low value, and then up and down the slope till we get a low value, kind of like how these arrows are indicating. And it's not like there's a magic number. It's just the lowest possible number we can find. Once we have that number, our beacons are no longer the tool we're going to find them with. We need to use our probes to find them. So the important thing with probing is to just use a consistent pattern. This pattern is going to be about 10-inch spacing. I think of it as like the size of my boot. You're going to hit a person with that interval. So you want to do a consistent, thought out pattern, and you want to do a repeatable pattern so that it's fast. You're going to know you hit a buried person because it's going to be a different height and a different feeling than the rest of the snowpack. This prober shows really good technique being perpendicular to the slope. Which direction? Perpendicular to the slope. So with shoveling, our goal is to get them an airway fast, and then ultimately to create a workable platform depending on how deep it is and what kind of injuries they have, so that we can extract this person. But the primary goal is to get to their airway, because that's what's killing them, is that they don't have good oxygen exchange. So the shoveling technique we'll teach is just effective at moving snow quickly. Once we have that probe strike, we're leaving the probe in, and we're trying to dig into the probe from the downhill side. So yeah, ultimately, like this course is only so many hours, and we can't do scenarios all day. We do teach rescue courses that focus more on scenarios, but we want to just acknowledge that avalanche incidents are emergencies, and the more kind of preparedness you can have ahead of an emergency, the better you're going to be able to respond to an emergency. So we hope to teach you the good techniques so you can go practice on your own, because being really proficient with your gear isn't going to happen in just one day or one afternoon. It's going to be, you have the good technique and you practice over time. So that's the plug with rescue. Yeah, our goals with the field day are to just get practice, to teach you some techniques, answer your questions, and give you an opportunity to practice. Does anyone have any questions? Hopefully I didn't put anyone to sleep. I am going to put the waiver link in the chat one more time, I think. Just because I don't know if everyone got it. Let's see. Here's the link. Okay. Yeah, so if you do have any questions that you didn't feel like you wanted to ask or you couldn't think of them during the call, you're welcome to just drop us a line or bring your questions to the field day. Specifically, if you have questions about gear or logistics or your field day, like just reach out to us and we can answer those questions. Haley, do you have anything else to add? Anything I missed?
I don't think so.
Well, we'll stay on for a few minutes in case someone has any more questions. But with that, we'll see you at your field day, and just reach out if you have questions. I don't
Thanks.
know if we'll have. All right, I'm going to stop the recording.